Welcome to Mathematics Square. Are you ready to master the geometry? Then you are on the right place. This video is dedicated to students who want to understand the complex maths concepts and clear the explanation by step-by-step solution. In this video, we will explore the first chapter, Basic Concepts in Geometry of Standard 9. In this chapter, we will see some concepts like line segment, ray, line, congruent segments and their properties. Also the points like midpoint of the segment, comparison of the segments, perpendicularity of the segment or ray, and distance of the point from the line. After this, we will work through the practice set and that will provide a solution to help you excel in your practice sets. So don't forget to subscribe and hit the bell icon, never miss your lesson. So let's start. First consider line segment. Now what is line segment? Let us consider the 2 points A and B. Union set of the point A and B and all the points between both of them. Their altogether union set is called a segment. Hence, A and B, these both are the endpoints and all the points between them, their union set can generate a line segment. So, line segment is denoted as, it is said, segment AB. It can be also called as segment BA. In both ways, it is the same only segment. Now, as it has a bounded boundaries, means there is a last point. So, we can calculate the length of the segment. So, how the length of the segment is denoted as? Length of segment is denoted as length for capital, for its length L, and it is AB. It is denoted as the length of the segment AB, and that is equal to also length of BA, that is also the same. Now, if we say that the length of this segment is 5 cm, for example, then we can denote it as is equal to 5. Otherwise, we can say that AB is equal to 5. In this way, we state that the segment length is 5. Okay. Now second concept is ray. Here we are saying ray AB. Now, a ray is some extended form of the line segment. Now here we can see AB. This much is a line segment. But we are having one more point P such that it is external to the segment AB, means outside of the segment AB, but in such a way that A dash B dash P, means P is outside of the segment AB. It is betweenness, B is between A and P. Then we can say that this is called as a ray AB. Okay. And like a segment, it does not has a bounded boundary from the one side. But we can say it has a start point as A, but there is no end point to the ray. So A is a starting point. A, but it does not has ending point. Like segment has a start point and end point. So it is end points are there. But there is only one end point for the ray, that is a starting point. But there is no bounded from the another side. This is called the ray. It goes continue in that direction. Now we have the third concept as a line AB. Now see, here we are having point P and towards the right it goes as a ray, and towards the left also it continue. If we don't consider this point, then this ray go towards the left side. Means we can say there is one ray which goes towards the right, and there is also one ray from the point B, it goes towards the left. Means these two are the rays in the opposite direction. They form 180 degree of angle. That is, they are the opposite rays. Right? These are the opposite rays. So line AB is a combination of what? The ray AB and its opposite ray. Right. Then we can say that it is a line AB. Now, as the ends are not bounded, means it doesn't has end points, so we cannot give the length to the line AB. It is simply said that it is a line AB. So it can be said that segment AB is a subset of line AB. Means because line AB can continue with some more points. So it is called the subset. Line segment is a subset of the line. Okay. Now, fourth concept is congruent segments. Now here we are having a line segment AB and the segment PQ, right? But if we consider that their lengths are equal, let's see the fourth concept, congruent segments. Now here we are having the segment AB and segment PQ. Now let's consider that their lengths are equal. That is, length AB is equal to length PQ. So now means if AB is 4 centimeter, then line PQ is as 4 centimeter. Means their lengths are equal. Then we can say that segment AB is congruent to segment PQ. This is a symbol for the congruent. It is called a congruent. This is a symbol for the congruent. Means their lengths are equal. Then they are called the congruent segments. Got it? Now, but in this congruent, we are having some properties. First property is reflexivity. We can say that each segment is congruent to itself. Means now any segment is congruent to, means it is equal to itself. So it is given by segment AB is congruent to itself. That is segment AB. It is called the reflexivity property. Means each segment is congruent to itself. Similarly, now second property we have symmetry. What is the symmetry property now? See, if any segment, means let us consider now segment AB is congruent to segment PQ. If this is our first statement, if we are saying that AB is congruent to PQ, then we can also say it in other way as segment PQ is congruent to segment AB. Means symmetrical. In both the ways we can say it is same only. then it is stated that segment AB is congruent to segment PQ, then segment PQ is congruent to segment AB. Okay, so second property is symmetry. It is if any segment is congruent to second segment, then the second segment is also congruent to first segment. In this way we can say. Now third property is transitivity. Now in this, if we can say that if we are having three segments like AB, PQ and EF. If we are saying segment AB is congruent to second segment PQ and PQ is congruent to third segment EF, then we can say segment 1 AB is congruent to third segment, that is EF. Means if first is friend of second and second is friend of third, then automatically first friend and third friend are the friends of each other. We say friend circle, from a friend circle, like that. So segment AB is congruent to segment PQ and segment PQ is congruent to segment third segment, that is EF. Then we can say that first segment is congruent to segment AB is congruent to segment EF. Okay, so we are having three properties of congruent segments. Reflexivity, it is said that each segment is congruent to itself. Symmetry, it is if first segment is congruent to second segment, then we can say that second segment is also congruent to first segment. And third property is transitivity. If the segment is congruent to second segment, second is congruent to third, then automatically first and third are congruent segments. Okay. Now, next concept is midpoint of the segment. Now say we are having the 3 points A, M and B. Those are such that they are in one line, that we can say betweenness. M is between A and B. And M point is such a point on this line segment AB that AM distance is equal to MB distance, means it is a midpoint of that the segment, and we can say that their length is equal. So segment AM is congruent to segment MB. Okay, means it divides the segment AB exactly from its middle. Means AM is equal to MB in lengthwise. So they are said that segment AM is congruent to MB. Then point M is called the midpoint. Is a point such that it divides a segment into two equal parts. It can be said as a midpoint. And every segment has only one midpoint. Means any point somewhere here cannot divide the segment into 2 points because it is having M point as a midpoint. Means a point midpoint is unique to each and every segment. Okay, there cannot be two midpoints to any segment. So this is called the midpoint of the segment. Now let's see the comparison of the segment. In comparison of the segment, we do the comparison from the length of the segment. Now see, we can see here the two segments, segment AB and segment PQ. So segment PQ is little bit longer than the segment AB. So we can say that the length of AB is we can say that AB is smaller than the PQ. And how it can be stated? It can be stated as length of AB is smaller than length of PQ. Right? Then this is called the comparison. We do the comparison by its length of this segment. Now if this is 2 centimeter and this is 5 centimeter, then we can say length of PQ is greater than the length of AB. This is called the comparison. Now perpendicularity of the segments and the rays. Now see, here we are having the segment AB, which is later on extended. This we can say that it is also line AB. And here we are having a segment CD. Now see, if this segment makes a right angle, is 90-degree angle with any line or a ray or a segment, then we can say that the ray CD is perpendicular to the line AB. The symbol for represent the segment or rays is perpendicular is like this. Now see, here we can say that segment CD is perpendicular to segment AB. This is the symbol for the perpendicularity. This can show that the segment CD is perpendicular to segment AB, means it makes a 90-degree angle with that segment or that ray or that line. Okay. Now, if we have to calculate the distance of a point C from the line, consider that the line is AB. Then now, here we have shown that the CD is perpendicular. Now see, if we are considering the point C, we are drawing the line. Now we can draw the many lines from the C to the line AB, right? It can be like this, can be like this. So this distance goes on varying. This is smaller distance, this is larger distance, okay. But when we want to calculate the distance of a point from the line, then we take a perpendicular to it. This is a concise way of calculating the distance. And it is called always it is the shortest distance among all these lines. So the distance is calculated how? This we can say that here CD is perpendicular to segment AB. Here also we can call segment CD. Segment CD is perpendicular to segment AB. Then we have to calculate the distance. Now if it is, we will consider it is distance is A, then we can say that CD is equal to A. Means the distance of the point C from the line AB is how much? A. Its distance is A. And here D is called the foot of the distance. Means this segment is drawn, then CD, D is a foot point. In this way, we have completed all the basic concepts of the line, segment, ray. Let's see the problem set 1.1. The first question is, the following table shows points on a number line and their coordinates. Decide whether the pair of segments given below the table are congruent or not. Now these are the points given A, B, C, D and E, and these are the coordinates -3, -5, 2, -7, 9 respectively. Now we have to see whether these segments is this segment DE and segment AB below are congruent or not. Now we have seen the definition of congruent, that if the length of the segments are similar, then those segments are called congruent segments. Now, to find the length, we have here the points and their coordinates. So from as we have seen in last video, how to calculate the distance, that is only the length between these 2 points will give us the length of the segment. Now coordinates of point D and E are, D has a coordinate -7 and E has a coordinate 9. -7 and 9. Right? Now, so which is greater? 9 is greater than -7. Therefore, how we can calculate the distance DE? The distance of between D and E, that is only equal to the length of the segment AB is equal to 9 -7. That gives us 9 plus 7 is equal to 16. Correct? Now similarly, we will also calculate the length of segment AB. Coordinates of points A and B are, A has a coordinate -3 and B has a coordinate 5. So 5 is greater than -3, right? Then we have to calculate now length. Distance between A and B is equal to length of AB is equal to, it is what? 5 minus -3, that's equal to 8. Sorry, here it's not a length. It is not length AB, it should be DE. Since segment DE is not equal to segment AB, therefore They are not congruent. So in this way, from the coordinates of the point, we can get the length of the segment, and from the length then we can compare those length. It is 16 and 8. So those are not equal. Therefore, they are not congruent segments. Similarly, there are another two questions you can solve in similar way. So from the coordinates, calculate the distance, and from distance you will get the length, and then show that they are congruent or not. Okay. Now we will see the next question. Question is, point M is the midpoint of the segment AB. Here I have drawn the segment AB. It has a midpoint M, means it divides the segment AB into two equal parts. If the segment AB is equal to 8, then find the length of the segment AM. Yes, we have to find the length of AM. And we have AB is equal to 8. This given. Right. Now, since M is midpoint of segment AB, therefore we have therefore AM is equal to 1 by 2, that is half of segment AB, right? Because it divides it into 2 points, 1 and 2. Therefore, AM is the half of AB, right? Therefore, in similar way, we will solve now is equal to half of root 8, and that's equal to 4, and therefore AM is equal to how much? 4. This is the answer. The main point we have to keep in mind here is that EM is a midpoint. Therefore, it will divide this segment into the two equal parts. Therefore, we can have AM is half of AB, and AB is given. Then we can calculate 4 AM. Now, similar way, there may be some another question in the problem set or practice set, that if they are given AM midpoint to one end distance and calculate the entire point, then it is twice the length. So the question may be asked in some different way, but this is only main point. We have to keep in mind that midpoint always divides the segment into two congruent segments. Therefore, in this way, we can solve the midpoint questions. So now, next question is, we have the three segments AB, BP and AP. Then we have to compare the segments. Now see, when we have to compare the segment, we just compare the length of the segment. Now we are having given AB is, right, AB is equal to 5 centimeter and BP is equal to 2 centimeter. Again, AP is equal to 3.4 centimeter. This is what given. Okay. Now we want to compare this. How we will compare? Now as 5 is greater than 3.4. 3.4 is greater than 2. Right? So in similar way we can write now AB 5 centimeter is for AB. Therefore, AB is greater than 3.4 is greater than AP. AP, right? And AP is greater than 2 centimeter is BP. BP is the comparison between the segments. So, this way we can compare the segments. When comparing the segment, we simply compare the length, which is a shorter, which is a larger. Okay. Now, next question is write the answers to the following question with reference to the figure. Here we have the figure which has the points T, S, R, P and Q. Now here are the below questions. We have to answer this with reference to this figure. Now let's see the first question. It is write the name of the opposite ray of the ray RP. Now R is here and P is here. As the ray goes towards the right side. We want to write the name of the ray opposite of the ray RP. Let me note down C. Ray opposite to the RP. Okay. Write the name of the ray opposite to the ray RP. Now opposite ray means a ray which is exactly opposite in opposite direction. So our opposite ray will go this way. So we can say opposite ray is RS or RT. This is the name of the. So the opposite ray to the ray RP is ray RS or ray. It can be also say RT or we can say ray RT. In this way, this is opposite to the RP. Now, write the intersection set of a ray PQ and ray RP. Now see, they are saying over here ray means ray PQ is in this way and ray RP. Okay, so RP ray will be continuing this way. So the point of intersection it will cover of the ray RP and PQ is PQ section also. So the intersection will be a ray PQ and we are having the ray RP. Ray RP will be continuing in the same direction because they are on the same number line and this will be so its intersection will be from P to Q, right? Okay. Then write the intersection set of the ray PQ and RP will be intersection ray is PQ. Therefore, their intersection will be PQ. Next question is write the union set of the PQ and sec QR. Union means all together. Therefore, sec PQ is P is here and Q is here and Q to R. Therefore, their union will be all together from Q to R. I will show you. The first one is PQ, right? P and Q. And another segment is Q to R means from Q continuing its like R. So their union will be, or union set will be seg Q R, right? Okay. So union set is Q R. Okay. Next question is, state the rays of which segment QR is a subset. You say Q and R. Segment QR is the subset. Means we have to find the set that is greater than the QR. So it can be said Q and S and Q and T, because QR is subset of that. Therefore, the sets that are greater than QR are QS and QT. So our answer is ray QR and ray QT. Okay, of which QR is the subset. Okay, right. Now next question is, write the pair of opposite rays with a common endpoint R. Now we have to find the opposite ray with a common endpoint R. The endpoints are what? From the point where the ray starts to proceed ahead. Means one side is arrow, one side is an endpoint. So R is an endpoint. We are having such a two rays, that is RQ and RT. And obviously they are on the same straight line, means they are making 180-degree angle over here, means they are the opposite rays. So their pair of opposite rays is what? We can say ray RT and what? Ray RQ. Okay. Okay. These are the pair of the opposite rays with a common endpoint R. Now next question of the figure is, write any two ray with the common endpoint S. Now we want to write common endpoint is yes, that type of rays. Now see, here we have the ray point S. So the rays that can be having a point endpoint as SR, SR, SP, SQ, ST. As the last question was only opposite rays, means those are in opposite direction. But here we can give any two rays. So we will give SR and SP. Any two of them we can give. So I am writing here ray SR and ray SP. Okay? Yeah. Good. As we, if they are not opposite rays, we can give any two rays. Next question is, write intersection set of ray SP and ray ST. Now say SP ray starts from S and to P. It goes in this way. And next ray is S towards the T. Those are opposite ray. So they do not have the intersection as a long, but as their endpoints are same, means S point. So their intersection set is S, because they are having one common point in both of them. Intersection set is S point S. Okay. So observe the figure properly and keep in mind all the basic concepts we have learned earlier: ray, line, segment, midpoint, perpendicularity, their properties, and easily try to understand the question, Then try to figure out from the figure given for the reference, and you can get the answers for this. So next question is answer the questions with help of figure, and figure I have drawn over here. Now we have the many points on figure and their coordinates are also given. And we are having some questions from that number line. We have to answer those questions. The first question is state the point which are equidistant from the B point. Now see, point B is over here. You can see it? Yeah. Then from point B we have to calculate which points are at equidistance. Now if we want to calculate that C and A, then we'll calculate their lengths, at what distance they are, and from the distance they are from the B point, we will then calculate whether they are equidistant or not. Okay, yeah. Now here is solution. So first we'll consider points A and C which have coordinates. Now A has a coordinate 0, 0 and C has coordinate 4 respectively. Okay, right. Now we are in the coordinates of A is 0 and C is 4. Now we will calculate the length AB and BC. Okay. That is equal to only distance between A and B, and that's equal to, now A has a coordinate 0 and B has a coordinate 2. Therefore 2 is greater than 0. Therefore 2 minus 0, that's equal to 2. Now similarly for segment B and C, okay, B, C, that is only equal to distance between B and C. And now B has a coordinate 2, C has a coordinate 4. 4 is greater than 2, therefore 4 minus 2, that's equal to 2. Now since segment AB is equal to segment BC, therefore we can say points A and C are equidistant. Now the next point we'll consider D because it has a coordinate 6, and the another point that is a P which has a coordinate -2. So therefore for segment PP that is only equal to distance between P and B is equal to, now P has a coordinate -2 and B has a 2. Therefore 2 is greater than -2. 2 minus 2, that's equal to 4. Similarly, for segment DB is equal to distance between point D and B. Segment DB, distance between D and B. Now D has a coordinate 6 and B has a coordinate 2. Now 6 is greater than 2. Therefore, we have 6 minus 2, that is equal to 4. So, now the distance is equal. Say PB is equal to say DB. Therefore, they are equidistant from the point B. That is, points P and D are equidistant from point B. Okay. So now, as there are only this much points, there are no further points. So we have to calculate only for this much set of points. That is, from point B we have C and A, and another set was D and P, and those both are the equidistance. Okay. Now, the distance between U and P, as on the number line we are not given the coordinates of the U and B, but on the number line each point goes on increasing by 1 unit, right? So now coordinate of -4 and here is -6. So this will be what? It will be -5. And similarly with V it will be 5. So coordinates of V are VU is -5 and 5 respectively. Okay, right. Now since -5 is smaller than 5, therefore distance between U and V will be what? It will be 5 minus -5, and that's equal to 5 plus 5 is equal to 10. So the distance between U and V will be what? 10 units. 0 minus 5 and here 5. 5 and this 5 in this 10 means our answer is correct. In this way, you can solve the questions. Mostly the questions here are related to distance only, and it is mostly depend on understanding the concept between segments, line and ray. So do see the entire video and let me know if you have some problem in this practice set in the comment section.